Thank you all for coming to this first Skywatch lecture, and I want to thank Jack McEnany, who has made so much of this possible. I really appreciate your support. As many of you know, next year next year will be the International Year of Astronomy. It commemorates the 400th anniversary of Galileo's first use of the telescope for astronomy. And there's so many things that we take for granted, so many scientific discoveries, so many instruments, PowerPoint. So much of this that we take for granted and don't really understand what goes into the background of it, what the human part of it is, why it's been developed in the first place. And there are things like time. If you want to know what time it is, you look at your cell phone probably, and longitude. Longitude is something that tormented us all in third grade when we needed to look at those maps and, figure out where such and such a city was. And, a lot of these things don't necessarily have, I guess it's hard to see the significance of them because we take them for granted. It's hard to see the human struggle that went into them, the need to develop them, the need to develop the instruments so that we could explore this world around us. And our speaker tonight is Dava Sobel, and she has done just a remarkable job, as we all know, making the history of astronomy, the history of science, human, and really bringing it to life, explaining to us why these things are pertinent to our lives. And I can't think of anybody better to start this lecture series. So, Dava, I really appreciate your coming.
Thank you very much. I'm really excited to be here. And we're trying all kinds of new things tonight, multimedia presentation. First I have to confess, I stole my title from Ed Krupp at the Griffith Observatory in Los Angeles. When the planning for the International Year of Astronomy started, he was head of a committee called Arts, Entertainment, and Storytelling. And we all got together and tried to think of artsy, entertaining, storytelling things we could do to celebrate the International Year of Astronomy. And a lot of them were really silly, and you'll never see them, thank goodness. But Ed came up with this mantra that the telescope really had changed everything. And he wanted us to focus on that. So I decided to make it the title of my talk. And I have already told him that I didn't really steal the title, I just implemented it. And because this year will affect people who are not yet interested in astronomy, we hope, it's important to find many ways to bring them in. So one of the things I want to do tonight is have some astronomy poetry. And we have volunteers in the audience who've already agreed to read aloud certain of these poems. There'll be 3 of them, so I'm excited about that. And because we threw a surprise at the technical people, I can't advance the slides, so I'm going to ask the technical genius up in the booth to please change to the next slide. Okay. This is an illustration from a lovely children's book called Galileo's Treasure Box by Catherine Brighton. And it gives a sense, I think, of that time 400 years ago when this wonderful genius heard about this new invention and, without ever seeing one, just hearing what it did, put one together and started using it in an unusual way. Of course, try not to pay attention to the fact that it is daylight in this picture. There had been talk for many years about magic mirrors, lenses that could do unusual things, but a telescope that could actually look into the skies did not exist before Galileo made his own version of this invention. You know, the people who really invented it, there's still argument about whether the actual inventor was Dutch or Spanish, but the Dutch have already had their celebration because they consider 1608 the year. So last week they had their big meeting and we all missed it. And by the 13th century, lenses for spectacles were common, so people could keep reading long after their youthful vision had failed them. So, may I have the next slide, please? Okay, this is the working end of one of Galileo's own telescopes. There are two telescopes that survive that are believed to be ones that he built by himself. And many beautiful replicas have been built, but this is one of the genuine ones. And you can see what a beautiful thing it is. It's just a cardboard tube with two pieces of glass, but it's got some gold tooling on it. And Galileo's first idea was to use it for military defense and turned it over to the Doge of Venice so that people could see enemy ships on the horizon. And it was only after that that he turned it up and discovered just about everything. And that advanced his career considerably. There never was a patent granted for this instrument because the Dutch Estates General felt that it would be too easy to copy. And within a few weeks of the presentation of this by Hans Lippershey, two other people came along with similar inventions. So Galileo did not invent it. He's often credited with the invention, but really he just made a better one and then used it in an unusual way. Before you go to the next slide is a movie. And through the magic of Nova TV, that is, not novas in the skies, we actually have film footage of Galileo with his telescope. I don't know if you'll be able, I wonder if the narration will play. Can that be louder? Yes.
The first telescope to reach Venice was a toy, a novelty, built to amuse partygoers.
Spectacles, compared to telescopes, are very low tech, but they have been around for several hundred years. It was only when lenses became available in certain range of strength that one could take the weakest convex lens and combine it with the strongest concave lens and get an appreciable magnifying effect.
Galileo set out to turn the Dutchman's toy into a useful device.
Hearing reports of a new invention from a lens maker in Holland, I determined to fashion a device for myself and was able to make considerable improvements in it.
Galileo realized that spectacle makers could not give him the lenses that he needed in order to make this device more powerful. They just weren't good enough, and they weren't the right strength. And so, in order to improve the instrument, he had to teach himself to find lenses. And that is extremely difficult. certainly wasn't 1610.
At first, Galileo was only interested in the optics of the telescope. With his improved lenses, he increased its power tenfold. But his lenses did more than magnify. By reshaping these pieces of glass, Galileo would eventually reshape our view of the world.
Okay, that actor was Simon Callow, and the talking head with the nice Dutch accent was Al van Helden, who has written a wonderful book called The Invention of the Telescope. So let's have our first poem about this wonderful instrument, the telescope. This snaps out. And this is a poem by Robert Frost called The Star Splitter.
Thank you. You know, Orion always comes up sideways, throwing a leg over our fence of mountains, and rising on his hands, he looks in on me, busy outdoors by lantern light with something I should have done by daylight. And indeed, after the ground is frozen, I should have done before it froze, and a gust flings a handful of waste leaves at my smoky lantern chimney to make fun of my way of doing things. Or else fun of Orion's having caught me. Has a man, I should like to ask, no rights these forces are obliged to pay respect to? So Brad McLaughlin mingled reckless talk of heavenly stars with hugger-mugger farming, till having failed at hugger-mugger farming, he burned his house down for fire insurance and spent the proceeds on a telescope to satisfy a lifelong curiosity about our place among the infinities. What do you want to do with one of those blamed things? I asked him well beforehand. Don't you get one? Don't call it blamed. There isn't anything more blameless in the sense of being less a weapon in our human fight, he said. I'll have one if I sell my farm to buy it. There where he moved the rocks to plow the ground and plowed between the rocks he couldn't move, few farms changed hands. So rather than spend years trying to sell his farm and then not selling, he burned his house down for the fire insurance and bought the telescope with what it came to. He had heard to say by several, the best thing we're put here for us to see, the strongest thing that's given us to see with a telescope. Someone in every town, seems to me, owes it to the town to keep one. In Littleton, it might as well be me. After such loose talk, it was no surprise when he did what he did and burned his house down.
Thank you. Well done. Thank you very much. And I love the line, that in every town there ought to be somebody with a telescope. And here we have Janie Schwab, we have Sue Friend, we have others probably too numerous to mention, which is one of the nice things about this town. All right, now we need the next slide, please. So this is what Galileo began with when he started looking at the heavens through his telescope. And this is his own drawing because he was trained as an artist and had that perspective to bring to his perspective drawings, which is how he could appreciate what he was seeing, because his telescopes were pretty difficult to look through. It was a tiny field of view. He probably never saw more than half the moon at any one time. And yet he was able to understand why there were light spots in the dark part and dark spots in the light part. And he realized that that must be the sunlight hitting the tops of tall mountains before the rest of those dark areas were filled in with the sun's light. And he was even able to estimate the heights of the mountains from his knowledge of geometry and perspective. So in that sense, he really did invent the instrument, because before, he also changed astronomy, which had been a science of position, of where the planets were going to be at various times, not what they were made of. And so this was a huge change. Next slide, please. And it's often said that Galileo was not even the first one to look at the moon through a telescope. Probably Thomas Harriot in England was first. But this is a map that Thomas Harriot made in 1611. And you can see it's all two-dimensional. So it doesn't have the same kind of appreciation, understanding, and information content that Galileo's drawings do. Next slide, please. As an artist, Galileo had lots of friends who were also artists, and his discoveries immediately had an impact on the art world. So this is his friend Ludovico Cigoli, who painted this sacred image at the Church of Santa Maggiore in Rome. And it's a very standard kind of image with the Madonna standing on the moon. However, the moon is now Galileo's moon. It's no longer this perfect crystalline object, but it is a real world, rocky, with mountains and craters. Next slide, please. And this is his full set of wash drawings of the different phases of the moon. He began with that. He worked from the end of November till the middle of December to see all this. And one of the things that's going to happen in the International Year of Astronomy is that people everywhere will try to see all the things that Galileo saw. And that would be great, because even with a mediocre pair of binoculars, you can probably do everything he did. And there'll be a new kind of inexpensive telescope made with children in mind, that these could be distributed all over the world to help people understand how much fun it is to look at the sky and really be able to see things. And just watching the moon for newcomers to astronomy, looking for the moon every day and noting where you see it and what it looks like, that is actually a terrific introductory course in astronomy. And one of the poems is about what all this study of the moon led to. You ready to read your Apollo poem? All right. This is by Stanley Kunitz.
Okey-doke. Earth was my home, but even there I was a stranger. This mineral crust, I walk like a swimmer. What titanic bombardments in those old astral wars. I know what I know. I shall never escape from strangeness or complete my journey. Think of me as nostalgic, afraid, exalted. I am your man on the moon, a speck of megalomania, restless for the leap toward island universes pulsing beyond where the constellations set. Infinite space overwhelms the human heart, but in the middle of nowhere, life inexorably calls to life. Forward, my mail to Mars. What news from the great spiral nebula in Andromeda and the Magellanic clouds? And here's the second part. I was a stranger on Earth. Stepping on the moon, I begin the gay pilgrimage to New Jerusalems in foreign galaxies. Heat, cold, craters of silence. the sea of tranquility rolling on the shores of entropy, and beyond, the intelligence of the stars.
We need to have a poetry night at the Observatory. Okay, could we have the next slide, please? Can we have the next slide, please? Oh, great. Well, we heard about Orion coming up, throwing his leg over the horizon. When Galileo looked at Orion, he realized that he could see 500 more stars than had been seen without the telescope, and 80 of them just in this region. And he was able to look at the Milky Way and understand that the cause of it was the densely packed stars, and that these could actually be resolved with the telescope. He didn't call it a telescope. He usually called it a spyglass or an instrument, a lens. The name telescope came up later at a banquet thrown in Galileo's honor, where a Greek scholar invented this word for seeing things far away. Next slide, please. These are Galileo's observations of the moons of Jupiter, probably his most spectacular discovery, because this discovery made him feel that he could begin to defend Copernicus. A big objection to the Copernican arrangement of the sun and the planets was the moon, the Earth's moon. If the moon is going around the Earth, then how can the Earth possibly move around the sun? It seemed that it would be impossible for the Earth to be able to move like that and keep the moon revolving around it. But once Galileo showed that Jupiter actually had 4 moons, and nobody questioned the fact that Jupiter they thought it was orbiting the Earth. But whether it had orbited the Earth or the sun, it was definitely in motion and had these 4 bodies going along with it. So Galileo felt that this could be used as the beginnings of proof for the Copernican model. And he made these notations. They look very casual, the little asterisks for the moons, but they are so precisely drawn. These have been analyzed in modern times and compared with planetarium programs that can roll the sky back to 1610. And they are really, really quite precise. And he had some people who refused to look through the telescope at all. Colleagues of his at Pisa just did not even want to see these things. They considered the telescope a trick of the devil, that there was something in those lenses that made people see things that weren't really there. And this gave Galileo the opportunity to make one of his great remarks, which was that this professor, having failed to see them while he was alive, perhaps would look at them when he died and was on his way to heaven. Okay, next slide, please. So this is more how we know these moons today. We even call them the Galilean satellites of Jupiter, but he called them the Cosmian stars, because just as he had used the telescope to get himself a good job with higher pay in Venice, now he used the moons of Jupiter to be able to go back to Tuscany and work for the Medici family. And so he thought he would name the moons after Cosimo de' Medici. But Cosimo didn't like that name because it sounded too general, like it could just be cosmic, and he wanted people to know that the moons had been named for him. So he suggested Medicean stars. And unfortunately, Galileo had already printed his little book announcing all these discoveries, so he actually had to paste a correction in all 500 copies of this book. And then later Kepler applied the term satellites, meaning attendants on a personage of great importance. Next slide, please. Another thing Galileo looked at and drew beautifully were sunspots. Actually, these days, there are no sunspots. Sunspots are drawn today very much the way Galileo did, which is to just let the sun's image fall through the telescope and then trace them on the page. When I was a kid, I always thought that Galileo had gone blind by staring at the sun to draw the sunspots, but he was much too smart for that. So he knew that looking at the sun would blind him. He did this. And we are in a period of solar minimum, and everybody's waiting for the sunspots to come back. But if you look at the Mount Wilson Solar Observatory website every day, they show a drawing of the sun, and they usually draw the sunspots. But these days there are no spots to be drawn. Next slide, please. So another thing Galileo realized would help him give support to the Copernican idea was to show the phases of Venus. And he figured that with the telescope, he could actually see that. And he was able to see the phases of Venus. But he still had trouble getting people to agree with him that this was a good argument. Next slide, please. And he wanted to make this public, the idea of the Venus phases, but Galileo was so argumentative and had made so many enemies that when he announced something new, people really attacked him. So he came up with a way of laying claim to a discovery without actually saying what he had discovered, by creating an anagram. So the point he was trying to get across was that the mother of loves, namely Venus, imitated the shapes of Cynthia being the moon. So in red, that's the discovery, a poetic way of saying it. But then he took the letters and scrambled them to say something else. And so the code sentence is the green one. And there he says that these incipient things are hidden from me now. Oh, why? Because he couldn't work all the letters into the anagram. And he sent that to several astronomers to see if anybody could figure out what he was talking about. And in the blue, Kepler was the only person who came up with a solution. So the blue is Kepler's solution, and you can see that what Kepler thinks Galileo has discovered is a red spot on Jupiter. The one that we see now wasn't discovered till the 1800s, so this was way ahead of its time. Next slide, please. Now, when he looked at Saturn, he was not able to recognize the ring for what it was. He thought Saturn had two large moons that just stayed put. They didn't travel around the planet the way Jupiter's moons did. He didn't understand why that would be, but his observation was that he had seen the highest planet, because Saturn was the farthest planet, the highest planet triple-bodied. So that's the red. Then he scrambled it. And this time he didn't bother to try to say something else. He just had a string of letters. And that was the riddle that he sent out. And again, Kepler was the only one who came back with a response. And this time, Kepler thought that Galileo had found two moons at Mars. Another discovery that would wait for the 19th century. But Kepler was really wanting to see 2 moons at Mars because since Earth had 1 and Jupiter had 4, he figured that Mars must have 2 because that was a nice numerical progression. And also, he felt that since our moon was here for our enjoyment, then there was a lot of enjoyment to be had at Jupiter, and probably Jupiter was inhabited, which might give you some idea of why Galileo and Kepler didn't correspond all that much. Later, Huygens was able to resolve the ring, and he also used an anagram to announce his discovery. And when you unscrambled the anagram, it said, "A thin, flat ring, nowhere touching, and inclined to the ecliptic." Since that time, actually, I have to jump up to fairly recent times, telescopes have changed from being just optical instruments to receiving all sorts of other forms of light. So we have radio telescopes, X-ray telescopes, infrared telescopes, gamma ray telescopes. And the next poem, since we've talked about Kepler's belief that Jupiter was probably inhabited, the next poem is about using radio telescopes to listen for intelligent life elsewhere in the galaxy. Ready?
We Are Listening by Diane Ackerman. As our metal eyes wake to absolute night, where whispers fly from the beginning of time, we cup our ears to the heavens. We are listening. On the volcanic rim of Flagstaff, and in the fields beyond Boston, in a great array that blooms like coral from the desert floor, on high wire webs patrolled by computer spiders in Puerto Rico, we are listening for a sound beyond us, beyond sound, searching for a lighthouse in the breakwaters of our uncertainty, an electronic murmur, a bright, fragile I am. Small as tree frogs staking out one end of an endless swamp, we are listening through the longest night we imagine, which dawns between the life and times of stars.
Thank you. Great. Happy to say Diana Ackerman is a dear friend of mine, so glad we got to read one of hers. Okay, could we have the next slide, please? Galileo, for all the wonderful things he did not get everything right. And in this image, these are more Jupiter moon images. And you see up in that corner, he has something he has labeled a fixed star. He observed that star twice, but it's actually Neptune. Again, by using planetarium programs running backward. Another discovery that would have been about 200 years before its time. He also never understood the tides because he came before Newton instead of after him. And he just could not understand the concept or accept the concept of action at a distance. And so, as far as he was concerned, the tides were the result of the Earth's double motions. So just as if you try to carry a bowl of water and walk across the room, it'll slosh. That's what he thought the tides were doing. And he also wrote poetry, and the last poem is his, and it's a riddle. So I'm going to read it to you, and then I want you to try to guess what it is. It's called Enigma. And this translation was made by Nani Binyami, who he was with the Italian Space Agency. I think he's with some other research organization now. But the amazing thing about this translation is that he actually preserved the rhyme scheme. Italian is such a musical language. You can rhyme in ordinary conversation, without even trying. But to make that happen in English is very difficult. Enigma. Monster I am, stranger in shape and form than the harpy, the siren, or the ghoul. There isn't on earth, in air or liquid pool, beast fit with limbs of such a varied form. No part of mine to another does conform, more than a white does to a pitch-black bull. Hunters I have oft aplenty, who will be hot on my tracks, acting in a swarm. In the darkest of dark is my abode, since if I move from shadow into light, presto, my soul will leave me, just like dreams will do after the cock has crowed. I watch my limbs disjoin and lose the fight, as life and name and soul give up I must. Any ideas? The moon?
Comet?
Who said comet? Very good, Jim. That's it. That's what it is. It's a comet. And although Galileo saw a comet when he was a child, he never observed one through his telescope. There were several that were visible in the years after his use of the telescope, but he was sick and never did get to see one, and he never accepted that they were beyond the sphere of the moon. Now, you would like to hear it again? Is that all right if I reread the riddle? Okay. Now that you know the answer, yes, okay. Monster I am, stranger in shape and form than the harpy, the siren, or the ghoul. There isn't on earth, in air or liquid pool, beast fit with limbs of such a varied form. No part of mine to another does conform, more than a white does to a pitch-black bull. Hunters I have oft aplenty, who will be hot on my tracks, acting in a swarm. In the darkest of dark is my abode, since if I move from shadow into light, presto, my soul will leave me, just like dreams will do after the cock has crowed. I watch my limbs disjoin and lose the fight, as life and name and soul give up I must. Pretty good, huh? Okay, next slide, please. This is a painting called The Allegory of Sight by Jan Bruegel the Elder and Peter Paul Rubens. And so the telescope has become an object that can be included in artwork, not just things seen through the telescope, but the telescope itself. And it's too bad that no one is using the telescope in these pictures because a lot of people didn't really understand what one was supposed to do with them. There's a wonderful story, a letter from Galileo's brother who lived in Germany. He was a court musician. And he was explaining what had happened when a telescope arrived for the Duke. And someone set it up for him, and he just took it out of the box and pointed it out the window. They didn't try to adjust the lenses or make sure it was clean or put it on a stand. And it was snowing. So they decided it wasn't really a very good instrument after all. Next slide, please. Another allegory. This one is called the Allegory of Sight and Smell. And the next one, please. So this is the Galileo spacecraft as it was being deployed right around this time of year in 1989 on the Space Shuttle Atlantis. And that brought views of the Galilean satellites 1,000 times better than anyone had seen. And this spacecraft was almost too successful. It discovered an ocean on Europa. The first time an ocean had been discovered on a body in 500 years. And NASA gets very excited about the concept of water and that has this feeling that where there is water, there might be life. So either to protect the life that might be coming to be on Europa, or to have a gigantic public relations moment, they decided to intentionally destroy the spacecraft by directing it to Jupiter while they could still control it. Because if they waited till it was out of control, then it, as a derelict, it could just blunder into Europa. So it met a fiery end in 2003 and is no more. Next slide, please. And this is the Galileo National Telescope, which is really a series in the Canary Islands. And it's really a suite of several instruments. And it's not the kind of thing that you pick up and look through, not the kind of thing that one person can use. And that's pretty much the way of telescopes now. They're large, multinational, a lot of them are out in space. And it's tempting to say that they've gone beyond anything Galileo could have imagined. But the nice thing about Galileo was that he always had that sense that he was at the beginning and that people would come later and do better things. So to conclude, I'd just like to read you what he said at the end of his last book, The Two New Sciences. It wasn't really at the end, but there will be opened a gateway and a road to a large and excellent science into which minds more piercing than mine shall penetrate to recesses still deeper. We don't often think of him as a humble person, but he did have that side of him. So I wish you all a happy International Year of Astronomy. I'm sure it will be very productive here. And I'm very honored that I got to be the first one to talk to you about it. Do you have any questions?
When I go out and look up in the sky, I see a myriad of points of light. I couldn't tell which one is a planet and which one is a star. How did these early people distinguish between them?
The question is, how did early astronomers distinguish planets from stars? Well, Galileo addressed that point. I think if you go out tonight, you'll notice there's there's one thing near the moon that really is brighter than any of the stars, and that's Jupiter. And that's one of the ways the planets distinguish themselves. Jupiter and Venus are much brighter than the stars. And when Galileo looked through the telescope, the stars always stayed points of light, no matter how much they were magnified. But the planets really did start to look like little globes. And with Venus, he could see the phases, the changes in the shape of it as it moved around the sun. Sure. Anybody else? Yes?
What was the power of the original telescope?
The Thomas Harriot telescope was, I think, about 6 power. Galileo went up to 30. Yes?
You said that Galileo observed the sun by projecting the image onto, say, paper, right? And that he did not get blind by looking at the sun. Did he go blind later in his life? And if so, how did he go blind?
When and how did Galileo go blind if he didn't blind himself by looking at the sun? He had a long history of eye trouble, even as a young man, infections. And he was plagued with a halo effect. If he looked at a light, it seemed to have a halo around it. He had that for several years. Probably since his real blindness set in old age, he had cataracts, glaucoma, just the typical kind of failure of age, and aggravated by sharing the telescope. Because if you do have an eye infection and you then pass your telescope to somebody else, you can pass the infection too. But people have wondered, nobody knows the exact cause, and there is an interest now in exhuming Galileo, which I hope they don't do. He's been moved already from one grave to another. I think we should leave him where he is, but there is some interest in trying to determine the cause of his blindness.
Thank you.
Anybody else? Yes?
What are your current books? What are you working on?
What am I working on now? I am working on a play about Copernicus, which I've been working on for a long time, and I'm still working. Yes, it's been very different writing a play because the goals are different, and as a person who's been a journalist most of my life, it's been hard to make that transition, but I'm interested and determined, so I'm still working on it. Question over there, yes? Do other planets have phases, and who discovered that? Well, the only planets we would see having phases would be the ones closer to the sun. So Mercury also has phases, but it's very hard to observe Mercury because it's so much closer to the sun. And you almost never get a good observation of it the way you do. Have you had luck observing phases of Mercury? Here you've... Yes, yeah, it should be doable. But anything that we see interior to us, so Mars and outward, we never see having phases. And it would be Galileo who discovered that. Yes?
Why are there not sunspots?
Why are there not sunspots? Good question. The number of sunspots cycles, and they have to do with magnetic activity on the sun. And so the sun goes through periods of increased and decreased magnetic activity. And so when there's minimal activity, you don't see many spots. And sometimes they can all disappear. But it's been a long time now. I mean, since the beginning of this year, maybe 1 or 2, it's very curious, and nobody really knows the answer. And there's kind of a crazy hope that maybe the sun is entering some kind of phase that will cool the earth and rescue us from the mess we've made with global warming. But I wouldn't count on it. Yes?
I understand that the Vatican is now erecting within its precincts a statue of Galileo.
Yes.
Can you say something about the relationship between Galileo and the Vatican?
Yes, the Vatican is erecting a statue of Galileo. It may already be up. I haven't checked, but I know that's definitely something that I've heard about. And could I comment on the relationship of Galileo to the Vatican? During Galileo's lifetime, because he knew the Pope, but wrote a book that defended the Copernican view of the arrangement of the cosmos, Galileo was tried by the Inquisition. And as a result of that, his book was banned, and he was sentenced to house arrest. So what was his crime? Was it really heresy? In the sentence it says he was vehemently suspect of heresy, not that he was really a heretic, because his main crime was disobedience. It turned out there were documents on file that said that he had been told long ago he was not to teach this idea, and writing a book was the same as teaching. And he had kind of forgotten about that, so he felt that it was okay for him to write this book. It's all a little fuzzy, so that for many, many years, that book stayed on the Index of Prohibited Books for 200 years. Long after it became okay to talk about the fact that the Earth really did go around the sun. That book received particular discrimination. But Pope John Paul II was a countryman of Copernicus and was very interested in science. And he was invited to speak at a celebration, I think it was the Einstein centenary. And while there, he decided to impanel a commission to re-examine Galileo's case, because to this day, there are people who hate the Catholic Church because of what they think it did to Galileo. So he wanted everything looked at again. And the panel was assembled, and it was divided into 4 subcommittees. Have you ever served on a committee? So, some people got sick, a couple of people died, other people were busy. It went on for years and nothing happened. One subpanel really worked, and they published a few summaries of their deliberations. But after a while, the Pope asked one of his cardinals, whatever happened to my Galileo panel? So the cardinal sent around a letter to all the members that their final report was due in 2 weeks, and there was a flurry of activity. And then this cardinal summarized all the findings and gave short shrift to the one group that actually had findings. So a statement came out that was very waffly. It said that Galileo had much to suffer and that he hadn't really understood the scientific issues at stake, and the theologians at the time hadn't really understood the theological issues. And overall, it gave the impression that there had been a tragic misunderstanding and a sense that there had to be a divide between science and faith. So what does that say, actually? People have interpreted that all sorts of ways. There was a lot of of sarcastic reaction to it. You know, people saying that, you know, 400 years later, the Vatican was ready to admit that the Earth went around the sun. There were humorous songs written, people wondering who would next be exhumed and pardoned. But the thing was, he wasn't pardoned. He was rehabilitated. And the subcommittee that didn't get heard in all of this, they are angry, and I don't blame them, because it could have, you know, it was an opportunity to lay all of those bad feelings to rest, and it was an opportunity missed. So we still have all this confusion. People will tell you that Galileo was excommunicated, that he wasn't buried in holy ground. None of that is true. So that's why he couldn't be pardoned, because he was not convicted or excommunicated in the first place. So that would be a nice thing to happen as a result of the International Year of Astronomy. If we're going to get Galileo's story straight and have peace around the new statue in Rome, that would be my wish. That and having everybody see the things Galileo saw. Thank you.
I think that was a beautiful way to end, you know, talking about our humanity, and thank you. This has been just so wonderful. And bringing history, art, astronomy, poetry all together. I want all of you to go outside with your pencils. Draw what you see, write poems about it. So we have another treat for you tonight. I mean, Dava has shown you what a beautiful job she does as an orator. And last year, I guess many of you were there when we were celebrating our...
I'm going to sneak out.
Oh, well, you can't sneak out yet. You have to stand like this. You have to stand like this for a very, very, very long time. There was a painting in the Albany Institute of History and Art of the Dudley Observatory's inauguration, and it featured famous scientists from all over the world. I mean, all of the famous scientists in the United States and some from other places, and the politicians and the businessmen, the people who had put up the money to build the observatory, and they all had gathered together for the inauguration. And then later, Tompkins Madison did a painting of it. So for the 150th anniversary, we decided to recreate this with all of our current supporters. And Dava got to take the place of Edward Everett, the orator, who spoke for 2 hours on the uses of astronomy. There are many uses of astronomy, as you can tell. And Jack McEnany, this was kind of, I don't know how it came about, but he got to be in the patron seat, and I'm sure that's what provoked him, gave him the ideas that he should sponsor this, gave us a lovely grant to get the painting printed, or the photograph printed. Anyway, I should invite down a few other people who were involved in this. Michael Oatman staged it, and Joe Putrock was the photographer. And one thing that was very dear to my heart, the original painting had some people in it who had not actually been at the inauguration. And in keeping with this, there was a few people that were very important to Dudley Observatory who were not able to be there. One of whom was Ralph Alpher, the often called the father of the Big Bang. And Ralph had been the administrator at Dudley for many years, and he died in August last year, so he was not there. But his great niece, Laura Glazer, was there, so she was on the stage, and I should let these gentlemen tell you what else happened. Are you still having your finger in the air, or do you? Or shall we grab a seat?
I think we should grab a seat and let them take over.
Well, thank you, Janie, and thank you, Dava, for a terrific lecture. I want to clarify a little bit for you the process of making this work, because I want to clarify for you a little bit the process of making this work, because like many collaborative projects and like much of my work, these projects usually evolve over a long period of time and have a lot of players. Janie contacted me and asked me if I would be interested in photographing people that were coming to this gala event individually, and then sort of cutting them out and assembling them together in a collage. I make collages. And I explained to her that I never really work with photographs in my work. I always start out with source images that began their lives as paintings that have then been reproduced in lithography and books. I work with a very narrow range of illustration from the 30s to the 70s to give the work a kind of consistency. So I never really worked with photographs. And I said, well, what is this for? And she's like, well, you know, we're entering into a new phase with the Observatory. We're trying to have this gala event, and we're gathering a lot of people together, and I thought it'd be a good opportunity to take these photos. And I said, well, you know, if you want to base it on the Madison painting, why not just assemble everyone into that position for one shot, rather than making me do all this hand cutting work? And I can think of a photographer that I'd like to work with on this project. And so many of you were there. I see some faces in the crowd that are familiar. I got in touch with Joe, and we agreed to work together. I've long been an admirer of Joe's work, which I know, you know, mostly through what I would call a kind of engagement with spaces and objects in a way that really showcases time and sort of the effect of changes in kind of culture and the environment have on things. And he's also done a lot of other work too, very diverse work. But I was particularly so we acquired some props that you'll see from places like Fadigan's Nurseries, these artificial trees that they lent us that were similar to the ones that were in the original painting. And I have to say, I don't know how you felt about it, but it went pretty smoothly. I think it took us about 45 minutes to get the arrangements together, maybe an hour tops.
But it took us 12 hours to set it up.
Right, exactly.
That day.
And it's taken, you know, 10 months to produce the final image. Before we do the unveiling, I just wanted to comment on the fact that I didn't realize that it was the International Year of Astronomy that was beginning. But I feel like for the past 5 years, I've had a kind of international astronomy phase going on in my life. Astronomy has re-entered my life in a number of ways, this project being one of them. In 2005, I went to Easter Island, the most remote populated place on the face of the earth, to make a film, which was entitled A Romance in Optics, which was a very personal project for me. I had started out at the Statue of Liberty on a Bedloes Island in New York City with a video camera, handing out quarters as people were getting off tourist boats, and I asked them to look through those viewers that you see at state parks, made by the Tower Optical Company. And I asked them a question. I said I would pay for their viewing, their 3 minutes of viewing, if I could videotape them responding to the following question, which was, if you could use this device to see anything from the past, present, or future, a person living or dead, an historic event, or something yet to occur, what would you most desire to see? And I think on that first day of filming, I filmed maybe 100 people answering the question. And then I took a portable version of that, one of those viewers, which meant in this case 190 pounds rather than 360 pounds, packed like a collapsing telescope into an instrument case such as a 19th century astronomer might have used. And I took that device to Easter Island, 2,500 miles off the coast of Chile, and hauled it around like a monumental head, as those heads there might have been erected, and posed the same question to tourists and residents of Easter Island. And this resulted in a film. And I have to say that my first night there, I very deliberately went out to the quarry where the giant moai, the heads, were harvested from, some of them 65 tons. And I had waited until, I had filmed people there that day at the base of it asking this question, but I waited to go walk around the Moai at night. I went around midnight. And it was a very powerful experience looking at these structures. You know, you really felt like you were in the presence of something. And then I looked up, and the Milky Way was scattered across the, you know, the sky like, very different results, but I think both of these projects have reminded me that the process of being an artist is a lot like what I imagine as a young science student, that this was something that I wanted to pursue as a career. But as a high school student whose math skills were woefully sort of underdeveloped, I realized that I was not going to have a career in science. But I, as an artist, come back to re-engage with kind of the romance of science through art making, through realizing projects like this. So, Jane, I want to thank you for bringing this opportunity to me. Joe, it was great working with you. And you folks, it was great working with you. Why don't we get some assistance here and we can unveil the painting, which is titled, excuse me, the photograph, which is entitled Observatory Time, after a work by the artist Man Ray. And it is, as you see, a sequel to the Madison painting. Lift it straight up. I hope you'll all come up and take a look in a few minutes, but I wanted to take you, maybe I guess we could move this. I wanted to take you on a little tour of some of the features of the image. Oh, thank you. If you were there, you remember the room at Chancellor's Hall had this massive green curtain, which went up, I think, another full story about this. And we really need to do something with that space, and so this star field was brought in as a way to kind of dissolve from the action of this kind of cultural event into the activity of the sky. We tried to preserve the orientation of the two trees. Flags ended up substituting for the bunting and the tent decorations. We were interested in including Ralph because obviously he had already passed away before this process was enacted. So here he resides inside this sphere, kind of ghostly presence participating in the proceedings. And in the original composition, as was pointed out earlier, Assemblyman McEnany occupies the chair of the benefactor here. But there was also a journalist in the original composition, and so Tim Cahill, who may at that time have been working for the Times Union, I'm not sure, is working at his laptop, and we have inserted painting. This is based on as the image on the screen in his laptop. 6 of you had your eyes closed. We scoured all of the negatives that were shot, and we could only find, that as a minimum number in one of the better shots. So we had to go into some of the other files that were maybe not as good as whole images and grab those eyes out and Photoshop them and open them. I was tempted to leave some of them, frankly. Some of my friends had their eyes closed. It was quite humorous. I'm trying to think if there's anything else that we did to the image.
Unlike the original painting, all these people have shoulders, which we didn't take into consideration when trying to put 150 people on the stage.
That's right.
In the painting, they just have no shoulders.
In addition to having produced this image, which has a frame that is similar to the one around the Madison painting. We hired my dad to make this frame. Joe has also printed up many copies of the image for me to take home tonight. and others will be mailed, I believe, Jane, is that right, to people who couldn't be here as part of this process? So I want to thank you for participating. I look forward to the next one in, whatever, 10 or 20 years, something along those lines. And I invite you to come up and take a look. Yeah?
Have you put together some notes on the things that you just noted about the picture, the things you had to do, the experiences you had? Have you written the story of this picture?
I think, the narrative will be produced at some point for the archives of Dudley, and I assume we'll make things like that available on the website. So we're looking forward to that. I'm looking forward to seeing the source painting and this hung together at some point. This one, we had to make it a little bit larger because this plaque was originally on the Dudley Observatory, and I wanted to include that artifact on this. The other painting does not entitle plaque, but this is one of the additions. It's a little bit bigger, but not by much, maybe an inch all the way around, in order to get the frame in order to get the plaque to fit sort of properly there. Yeah.
And you have a neat telescope in there too.
That's right. We had a gentleman show up in period dress with this great Japanese telescope. Is he here tonight?
Yes.
Very lucky, that's a nice telescope.
That's great. Are there any questions before we take a gander? Well, thanks again.
Thank you all again for coming, and we have the pictures up here. Excuse me. And we have envelopes to put them in too, so I hope everyone will get one and find yourselves. No touching though, no touching. Thank you.